Okay, so we'll start the class today. In previous class, we discussed about how to design a knuckle joint. So today, we'll take up one numerical problem, how to design a numerical problem on this knuckle joint. Then we'll close this topic also. Okay, so again we'll recall what is the design procedure, then we'll take up the problem. So here in case of knuckle joint, the first parameter you need to calculate is you need to calculate the diameter of the each rod. The diameter of the rod is calculated by considering the tensile failure of the rod. So this is the first step. So the equation for that it is P is equal to 5 by 4 d square into sigma d, where d is the diameter of the rod. So once you calculated this, then d1 is taken as 1.1 d from the using this empirical relation. So that is d1. Then what you need to do is, again using the empirical relations, you need to determine the values of small a and small b, which is 0.75 d and 1.25 d. Then you need to calculate the diameter of the knuckle pin just by considering the shear failure of that knuckle pin. So we know it is in double shear, so you need to use the double here. You have in this equation. This is the equation. Of course, here you need to use 2 into 5 by 4 d square into tau is equal to p. So this is the equation what you need to use. So from that, you can calculate what is the diameter of the knuckle pin. Then, if you got this d value, then your d0 and d1. Of course, if you use this is the equation, then you need to check for the bending stress. If you use bending stress equation to derive to determine the d value, you need to check for the shear stress. So that is the point you need to remember. Once you have a d value, then you need to calculate. You need to identify the dimensions of d0 and d1 using the empirical relations again. 2d, d0 is equal to 2d, and d1 is 1.5d. So then once you've done that, then you identified all the diameters, all the dimensions of the joint. Then you need to check for whether with these dimensions the stresses in the components are within the allowable limit or not. So first we'll take up I. So you need to check what is the tensile stress, bearing stress and shear stress in the I. Then similarly you need to consider for fork also. So you need to consider for fork also what are the values. So then if you calculated the sigma 3, sigma c, tau for fork and I, if all these values are within the allowable limit, then you can say whatever dimensions is chosen for the joint, that is d0, d1, a, c, then here d, here this d. So then it is safe. Those dimensions, with those dimensions, your joint is safe. So we can say like that. So this is how you can design this knuckle joint. Okay, so that we already discussed. This is the procedure. Then we taken up this problem also in the previous class. We discussed about this problem also. So I think you might have noted down all this problem. It is required to design a knuckle joint to connect the two circular rods subjected to an axial tensile force of 50 kilonewtons. Then the rods are coaxial and a small amount of angular movement between their axes is permissible. Design the joint and specify the dimensions of its components. Select suitable materials of the parts also. So here, in this case, he has not given the parts, the material properties. That is, the allowable stresses he has not given, but ask you select those materials and then their properties. So this is the important thing what you need to do. Sometimes they may give the question like this also. Instead of giving the allowable stress values, they will ask you pick from the data book. Okay. So now coming to this part, how we can select the materials for the parts. So then what you have to do is you have to look at what is the failure criteria. So in all the parts, if you assume all the parts are failed by yield, then yield strength is going to be your criteria. So that's what I written in this one. Selection of material The rods are subjected to tensile force. Therefore, yield strength is the criteria for the selection of the material for rods. The pin is subjected to shear stress and bending stress. That's what we seen already in design procedure. We have seen. So you can estimate the diameter of the pin based on either shear stress criteria or shear field criteria or bending stress criteria. So that's why the pin is subjected to shear stress and bending stress. Therefore, yield strength is also the criteria for the material selection for the pin. Then, on the strength basis, the material for the rods and pin is selected as plain carbon steel of grade 30C8. So, here, once you decided your failure criteria is the yield criteria, generally we'll use steel for this knuckle joint. So, then you can select any grade carbon steel. So, it need not be always 30C8. So, depending upon your choice, you can pick it. So here in this particular problem, you picked it as 30C8. So don't think that always you need to pick 30C8 only. You can pick some other one also. But only thing is, whatever material you pick from the data book, you need to take its corresponding yield strength. Not here for this 30C8, the yield strength is 400 Newton per mm square. If you choose some other 35C8, so then from the data book, you need to pick its corresponding yield strength. Okay, so that is the one thing. Once you pick the yield strength, so we require sigma T and tau sigma C. So these are the three parameters we require. These are the three allowable stresses we need to identify for this joint. So once you pick the yield strength, then your sigma T and tau is decided. So we know that your sigma T, if you use some factor of safety here, your sigma T by factor of safety or SYT divided by factor of safety. SYT divided by factor of safety is nothing but your sigma T, and your tau is nothing but SYS divided by factor of safety. So your SYS is nothing but 0.5 SYT. So then these two parameters are identified. Then what about this C, sigma C, that is compressive stress, bearing stress, we'll call bearing stress or crushing stress. So here for that what he has given is, it is assumed that the yield strength in compression is equal to the yield strength in tension. So that means he is assuming that SYC, yield strength in compression, is same as yield strength in tension, SYT. So that means once you have SYC value, so then you can calculate sigma C. Sigma C is nothing but SYC by factor of safety again. So that is, this is here in this particular problem, he made assumption like that, but you cannot take like that also. Since you have a data book with you, so in that data book, if he has given SYC value also for the material what you have picked, you can take SYC from that one and then apply factor of safety for this SYC, you will get sigma C value. Okay, that's it. So that is this part, select suitable material for the parts. So that means you need to identify what are the allowable stresses in tension, in shear and in compression or in crushing. So once you decided that, so then the remaining procedure is same. So but in this problem what he assumed is, he assumed yield strength is compression is same as yield strength in tension. So that means your SYC is same as SYD. So it need not be the case always. So if you want, you can take the exact value what you have taken, what you have in the data book. You can pick that value and you take that one as SYC. Then apply factor of safety to that SYC. Then you will get your sigma C value. Okay. So once you done that, then the remaining procedure is going to be same. So in stress analysis of knuckle joint, the effect of stress concentration is neglected. So generally, if you see the design procedure, no way we consider the stress concentration. So therefore, to account for this effect, only a high factor of safety of 5 is assumed in present design. So we already discussed that we need to select some factor of safety in order to determine sigma T, tau and sigma C. So then the criteria for that factor of safety here is, so since we are ignoring the stress concentration, you need to pick a factor of safety of 5 or above. So here you picked it as 5. So then once it is done, then calculation of permissible stresses. So that is sigma T, sigma C and tau. So your sigma T is nothing but SYD by Fs. So SYD for the that is C8, it is 400 MPa divided by factor of safety is 5, comes out as 80 MPa. Then sigma T is SYC by Fs. Since he assumed SYD is same as SYC, so therefore it is 400 by 5. Again it comes out as 80 Newton per mm square or 80 MPa. Then tau, that is allowable shear stress is 0.5 SYD by Fs, which is 40 MPa. So once identified these values, so then the remaining procedure is this one only. So what you have to do is, you have to first use this relation. First step is you have to calculate what is the D and then what is D1, and then you need to pick A and B values. Then you need to determine what is the diameter of the knuckle pin, and then you need to check for the diameter of knuckle pin. You need to check for the bending stress. The bending stress is nothing but your sigma B and sigma T and sigma C. You have to compare both. Because of bending, you have both positive and negative values. So you have to compare. Once you got the sigma B value, so you have to compare it on either side, sigma T and sigma C with sigma T and sigma C. Then, if they are within the allowable limit, then your design is safe. Then you need to pick D0 and D1. Then again, you need to check for the three stresses in both I and 4. Okay, so that's it. I think so. This is the procedure what you need to follow. So I think you have this procedure with you. So just you try to solve this problem now. So if you have any difficulty, then you raise a question. I will answer your question so that it will be completed. So we have plenty of time. That is, so you need to complete it. Everybody need to be completed this problem today. So you need to upload that. Whoever attending the class, they have to complete this problem and then they need to upload in the classroom. Okay, right? So you do it. So if you want to note it down these values first, you can note it down these values. So I'll give you some time for you to note it down these things. Then you start solving the problem. Okay, if you note it down this, then take this one also. Okay, note down up to that part, then we'll see. Then you need to complete the remaining solution. So this is the calculation for a D, that is the diameter of the rods. So you got diameter of the rods as from the calculation as 28.21 mm, which is rounded up to 30 mm. Then D1 is going to be 1.1 D, which comes out as 33, rounded up to 35 mm. Then your A and B are taken as A is 0.75 D and B is 1.25 D. They are taken as 25 mm and 40 mm. Of that, the diameter of the pin can be estimated based on the shear failure now here. So it comes out as 28.21 rounded up to 30. Then again from the bending failure, this is the calculation for the bending point of view. From the bending point of view, it is 40 mm. So therefore, out of those two, you have to pick the maximum value. So maximum value for the diameter of the knuckle pin is 40 mm. You note down this. First this. Okay, there is all these things. I think you already noted down these things, part 1 and part 2. Part 1 is selection of material, you already noted down. Part 2 is selection of factor of safety. And part 3 is calculation of permissible stresses. Then part 4 is calculation of the dimensions. In that, first the diameter of the rods, then enlarge the diameter of the rods. Note it down. Or else if you already done it, it's okay, well and good, otherwise you note it down. Then these things, dimensions of A and B, and then diameter of the knuckle pin based on the two criteria, that is shear failure. The first one, this one is for the, based on the shear failure, and this one is based on the bending failure. So you have to pick the largest value. So finally 40 is picked for the diameter of the knuckle pin. So simply don't copy the values. Check the dimension, the calculation part, you need to check it. Whether they are right or wrong, you need to verify just by calculating these values. Okay, once you have done that, then once you have D, you can take DO and D1 as 2D and 1.5D, so which comes out as 80 mm and 60 mm. Then you need to check for the stresses in I. So first tensile stress P by B into D naught minus D comes out as 31.25 Newton per mm square, which is less than the allowable stress, that is 80 MPa. Then sigma C is P by B into D, which is 31.25, which is also less than the allowable stress. Then shear stress is equal to P by B into D naught minus D. If you compute that, it is 31.25, which is also less than the allowable shear stress. So that means there is no problem with the dimensions of I. Similarly, you need to check for the dimensions for the fork also. So, okay, anyway, so first you note it down these things, then we'll go to the next one. Hello. లేదు ఎక్కడ ఇది ప్రజెంట్ సెకండ్ ఇయరా అనేంత ఎవరు లేరు లేదు లేరు లేరు So then finally you need to check for the stresses in the fork. So similarly sigma t, sigma c and tau are estimated based on A, D naught and D. So you can see that sigma t is less is 25, sigma c is also 25, which is less than our 80 MPa. Tau is 25, so tau is also 25, which is also less than 40 MPa. So that means all the values are safe. So then the design is safe. So that's all. That's how you can find the solution for this. Okay, just you note it down and then upload in the classroom. So with this, we close this one also, knuckle joint also. In the next class, we will try to start the new one, that is springs.